Now let's try letter C. So I see there's x's on both sides. I'm thinking, okay, is it possible to choose a logarithm, choose the base that works for a 27 and a 9? And the answer is yes, I can do a log base 3. That will work quite nice with both of them. And 9. Because log base 3 of 27, that says 3 to the what gets me 27. Well, just a 3. So this thing will become just a 3. And this is 3 to the what gets me a 9. Well, the answer is 2. 3 squared. So that's why 3 works for both of these. But first, I can't do that. I got to bring down my exponent and turn it to a multiply. Oh, whoops, I forgot the multiply brackets there, but there we go. Now, like I said before, this log base 3, 27, that is just a 3, and you need to just know that. You need to know how to do that. And this is an x plus 1, this is just a 2. So I would go back and look at the notes and do the worksheet that had us practicing, well, what is this? Evaluate that. What is that? Evaluate that. So I think that was back in the first chapter. Now 3 times 3 is 9, so this is a 9x. And you can bring the 2 into here to get a 2x plus 2. So I'll minus this 2x over to the left, and I'll just get a 7x is equal to 2, where I can divide both sides by 7. So x equals 2 over 7. So if you need to pause this, you can, but you can also take a look at the notes because they are already posted. At least they should be. Okay, so here's where we're getting a little bit more difficult. I see a fraction, but that doesn't really mean anything. It just means it's going to be a negative exponent. So if you've done your practice, like I'm going to do log base, is it 3? Yeah, 3 would. Log base 3 of 81. That would be 3 to the what gets me 81. Well, that's a 4. 3 times 3 is 9, times 3 is 27, times 3 is 81. So I know that, but if it's a 1 over 81 like I have here, well, how do I get that 81 to the bottom? Well, it must have been a negative exponent that would have put that to the denominator. So my answer for this is negative 4. So, well, I've already done that part, but I notice here that there's not an x on both sides, but I'm still going to choose a number that works for both of them, which is in this case, what was it, a 3? So log base 3 on both sides. 1 over 81 equals 27 to the 2x minus 4. Now this, again, we just did. That's a negative 4. There's nothing on the other side. And this exponent can come down and turn to a multiply. So a 2x minus 4. And this is a log base 3 of 27. So 3 times 3 is 9, times 3 is 27, so this just becomes a 3. So this is a negative 4, this is a 2x minus 4, and this becomes a 3. So negative 4. Now this 3 can come in, it'll become a 6x minus 12. And this becomes a really simple solving question at this point. At least it should be simple. That's an 8. And a 6x. You still might make a mistake, but it's only a two-step equation. Divide by 6. So x equals 8 over 6, or reduced 4/3. So what was difficult about that? I don't know. There is not an x on both sides. I think choosing the base 3 might be kind of difficult, because it's not very often we go 3 to the power of 4, like 3 times 3 times 3 times 3, and just knowing that's 81. But obviously the 1 over 81 and making this thing a negative 4, it must have been a negative exponent. That would probably be one of the most difficult parts about that. Which is why I did it again here for letter E. Thought we might as well try that again. So I have 16 and 32. So I have to do log base 2 for this. Because log base 2, because it goes 2 times 2 is 4, times 2 is 8, and then 16, 32, 64. So 16 and 32 both happen with a log base 2. So I have a 1 over 16 to the negative x, and a 32 to the x plus 4. So I can bring this negative exponent down, and I can bring this x plus 4 down. So this is a log base 2 of 1 over 16, and this is a log base 2 of 32. So again, we don't, unless you practice this, these won't be completely obvious. And so this is just a 5, and you would need to know that 2 to the power of 5 is 32. And this 2 to the power of 4 is 16. So the exponent would have been a 4. 2 to the 4 gets me 16. But how do I get this 16 on the bottom? Well, it must have been a negative 4, because the negative exponent would push things to the numerator. So it's negative 4. There's still times the negative x, and there's still times the x plus 4. So I've got negative times negative is positive, so I got a 4x. And here I've got a 5x plus 20. I'll multiply that 5 in. So I'll bring the 5x over, I guess. So minus 5x minus 5x. So I get a negative 1x versus a negative x is equal to 20. And then I can divide both sides by negative 1, and I'll just get an answer of negative 20. So that is my final answer for that one. What's the most complicated part? Well, maybe knowing base 2 works for 16 and 32, and obviously the fact that this is a negative 4 might make things a little more challenging. Okay, but let's do letter F, the most difficult question. So first of all, we're going to choose a log. Now that's not too bad. I'm going to choose a log base 2, both sides. So I have 4 to the x plus 1 equals 2 to the x plus 1 times 8 to the x. And notice I put that times in there just to clarify. So before I do anything, this is where knowing your log laws is going to become really important. Because we know that if a log law has two things on the inside that were multiplied, sorry, if there is a logarithm where two things are multiplied, there is a log law that allows me to do this. 2 to the x plus 1 plus log base 2 to the 8x. So when two logarithms are being added, we would have put them together and turned it to a multiply. So because these are a multiply, we can split them up and turn it to an add. And you have to do that because you can't bring exponents down when there's two different exponents. They have to be separated like this. So I'm going to bring this x plus 1 down as a multiply, bring this x plus 1 down as a multiply, and bring this x down. I will definitely do a question where there's multiplying. Like I have to. Like this tests you with your log laws. Or make it a division. If it's division, then just make it a subtraction. I might have a question like that in the worksheet. So this is an x plus 1. And this is an x plus 1. And this is an x. So I've got a log base 2 of 4. Log base 2 of 2 plus log base 2 of 8. So the exponents came down, just leaving the other numbers. So you're going to need to know your logarithms here to know what they are. So this, it would just become a 2. 2 to the power of 2 is 4. This is just a 1. That just cancels out. And this is 2 cubed. So that would be a 3. So I can bring this 2 in. I get a 2x plus 2 is equal to, there's nothing there, just an x plus 1. So I'll just move over now. I'll just move this x. I'll subtract this onto this side. Then I'll minus the 2 over to this side. So 2x minus x is just a 1x, and 1 minus 2 is negative 1. So all of this boils down to negative 1, assuming that's right. Unless I'm missing, oh, I forgot. Look at this. No. There's a plus 3x over to this side. Of course there is. So I got a 2x plus 2. is equal to, there's an x and a 3x, that's a 4x, and there's that plus 1. So I can minus the 2x, I'll do that this time, over to that side, and I'll minus the 1 over to this side. So it looks to me like 2 minus 1 is 1, 4 minus 2 is 2. So now if I divide both sides by 2, I get x is equal to a half, which is still not bad. So that's really nice. So that is that. What's the most difficult part? Well, choosing log base 2 I would not say is difficult. I would say knowing that you have to take this and split it up to a plus. Guaranteed half the class will forget about that, and they'll just log both sides and leave it as a multiply or something like that. Get an x squared, and then it just becomes a quadratic, and it gets pretty gross. So knowing that is probably the most difficult part, which is why I would say you should always practice the worksheets. So I'll zoom out here for what it's worth. If you need to copy anything, however, the notes already have this printed. So there are 3 examples now that we're going to do in the next video where it's impossible to choose a logarithm with a nice base. So we just do log base 10.